ask why is the difference between point shriek and point star back really Eisenstein?
Yes. So let me give a proof in SL2. The proof in the general case is slightly more complicated. But in SL2, it's like the following picture. So we'll write this 1 and omega. We'll do it as follows. So we'll go to 1 and omega mod. Yeah, so G is GL2. The Coles morphism R modulo GM. So GM is the Cartesian M. So
Is not the Cartesian.
that's also
Yes.
Going to Bungie. But so this is really close subset in Bungie. So if I didn't quotient by GM, it wouldn't be closed in Bungie. And that sits inside Bungie bar. And so this is the morphism we call P. Let me call this. Let me call it Pn P from P bar. So P bar is proper. So I have to control the difference between shriek and star on. Let me call this J. So two things will happen. This morphism is also not proper. It's fortunately by GM. So I have to control two things. I have to control R low shriek of the exponential cone of R star right to the exponential. And once I end up here, I have to control what's happening on the boundary. But here is a remarkable thing which is specific to SL2. And I also am on a particular component of Bungie, namely that has to do with the degree of this omega. It's 2G minus 2 component. So I claim that everything here outside of this open subset is in this unipotent Gerb situation. It's pulled back from Bun T, and therefore, when I push it forward to Bun B, I fall into the definition of Eisenstein. So let's see why that is. So what are things in Dirichlet's compactification outside of this? So these are the wishes. Oh, we didn't define it, so it was mentioned in. Was it mentioned that Justin's talk? Oh, he what?
I think it appeared at some point, but also in the same stuff.
It was used but not used.
Say again?
Used it.
Yeah. So okay. So there is some. We'll do it in a moment. So the point is that all the fibers are, all the other strata are unipotent gerbs over Bun T, and so everything that happens outside here on this particular component is already Eisenstein. So what we have to do is compare this. So here the following phenomenon is happening. So this is called the Cartesian diagram. Here it's A1, the evaluation of which A1 was 1 GM. So here we pull push, same old push pull. So let's see what happens with the exponential when we do this. So what you're doing, you're averaging the exponential with the shriek on A1 with respect to GM versus star. And what you see when you do this, it will be J lower star of the constant sheaf, where J is the embedding of the complement of 0 inside A1 of 1. And here it will be J low shriek. So funnily enough, this shriek averaging produces J lower star, and the star average produces J lower shriek. And the map is the following. So this guy canonically maps to the delta function of the origin. This map receives. So this map looks like this map. And if you look at the cone will have two copies of the constant sheaf. And again, those are Eisenstein. So this is the phenomenon.
And is this representative of the general G trace or?
So I have a very precise reference. So like with the general G, it's a beautiful picture. I call it Whittaker versus Kirillov. It's section 7 of the paper that Sam and I posted in archive in Lamont's volume. So I think it's just called Whittaker versus Kirillov, right? Or whatever. Yeah. So like we explained this picture in general. It's really beautiful game worth knowing. So we don't use these degree considerations. We don't. Something else is used, kind of even more robust.
Integration with the degree consideration.
Yes, this argument for SO2, it appears in Kevin's thesis. Where's Kevin? Okay, yes.
Even for general G.
No, but that had a mistake.
But then you fix the mistake.
Yes.
Yes.
Yeah. Yeah. Oh, so yeah, in the version of Kevin's paper online, there is. So Kevin, I'm forgetting what your fix is different, right?
What?
Your fix is different. It's not Kirillov versus Whittaker.
Yeah.
It is Whittaker versus Kirillov. So the two references, one is Kevin's paper, where exactly this version appeared, another is a paper of Sam and myself.
Maybe splitting hairs a little bit. So I guess this says that if I apply EL, they start to agree. Do they already agree after J uppers, like after restriction to this?
No,
Okay.
no. It's they. No.
There are two parts in there. There's the answer. The first part, at this part, second.
Yeah. So the really difference is really Eisenstein, nothing more, nothing less.
Okay.
Maybe.
Yes.
Could you explain what's on the second line over there? How is there duals? First,
So this is a questionnaire. Let me try to fix what I wrote there. So then everything will become clearer. Okay. So give me 5 minutes to draw my diagram, and I'll fix what I was doing. So just I'll think about good questions. I'll draw something in the blackboard for myself, and I'll fix what I've done. We can declare it as question time, so it's like the clock is over.
right.
This is just so okay.
Oh, J, okay.
Remember, it's a mistake.